problem 22490, circular sentence. This is Leetcode Easy. It was just released on the most recent competition, so hopefully I am the first person to address this problem. Yeah, let's go ahead and get right into it. So a sentence is a list of words that are separated by a single space with no leading or trailing spaces. Okay, so for example, hello world, hello world are all examples of sentences. Words only consist of uppercase letters and lowercase English letters. Uppercase and lowercase English letters are considered different. Okay, so it's case sensitive. A sentence is circular if the last character of a word is equal to the first character of the next word. The last character of the last word is equal to the first character of the first word. For example, Leetcode exercises sound delightful are all circular sentences. Why? Because the last letter of Leetcode is the same as the first letter of exercises. The last letter of exercise is the same as the first word of sound. The last letter of sound is the same as the first letter of delightful, and the last letter of delightful is the same as the first letter of Leetcode. However, Leetcode is cool, happy Leetcode, and I like Leetcode or not, circular sentences. Given a string sentence, return true is circular, otherwise return false. Okay, so to do this problem, the simplest solution is, well, simplest thing to do would be to just make a words array, which is based on splitting sentence on the space character. That way we'll get the words as they are by themselves, right? By themselves. So if you have Leetcode exercises sound delightful, right? If you split and you split on space, you have Leetcode, then this word, then this word, then this word. So now it's really easy to look at each individual word because each individual word is just a member of this array that you've created. And then you can just assert that this kind of condition is true when you look at this array, right? So you look at each word and you say, well, if the word at I, the last character at that word has to equal the first character of the next word, so the I plus one word. And that has to be true for each word, so that'd be I in range. Well, we start at -1. That way we can look at the last word and compare it to the first word, and then we can just cycle through, right? So we look at, can we compare delightful to Leetcode, then Leetcode to exercises, then exercises to sound, and sound to delightful. -1, 2, length of words, -1, because we're going I plus 1, so we don't want to go over the system, right? The last thing we should compare is sound to delightful. And then that's it. I'm trying to think if I'm missing something here. So this will get us to the answer. And then if we just submit that, we should be gravy. So this is O of n time and O of n space, right? So we have to look at each letter in order to generate this words array. This words array is going to take each sentence and then split it into a system. So now we have to create n additional space to create these words. But this is probably the easiest solution to comprehend. Another solution you could do is, well, if we look at this and we wanted a constant memory, we could have like 3 pointers, left, right, or left, center, and right. That could be kind of a sliding window approach, right? So we could look at these and say, okay, because since we're only looking at the last letter and the first letter of a system, we know that we're looking at a last letter and a first letter if the C is equal to space, right? So if C equals space, that would mean that L and R would have to also be equal, because that would mean that we're looking at the first letter and the last letter of a system, right? So we do that. This, no, we don't need to look, we don't need to look, don't need to look, don't need to look. Here, again, C equals space, so we need to compare the last letter to the first letter. So we have these kind of sliding window of size 3, which is 3 pointers, L, C, and R. And if C is a space, the center one, that would mean that we're at a space, so that there's a word to our left and a word to our right. So for the word to our left, the last letter is going to be L, and we need to compare that to the word to our right, first letter R. We do it at the end, and then at the end, when we get to this condition, the last thing we'll look at is here, and in this case, R will have to equal the first letter of the entire system. Okay, so we can just do that here, so we can look at each index in range length. We'll start at 0 and we'll go to the length of the sentence -2, right? Because R will go all the way to the right, but there's no point in like making right? For this example, there's no point of having anything larger than LCR like this, right? This doesn't make sense. This doesn't make sense, for example. Okay. So with that, we look at this example. So we'd say, well, we'll have L, C, and R. So left, center, and right equal to the sentence at I plus 3. So get those 3 letters. So those will be saved in L and C and R. So if we printed L, C, and R here, just so you can see what's going on, right, we should see L-E-E and then E-E-T and then E-T-C. Oh, for some reason, this happens to me a lot. Someone watching this right now is screaming because my indents are all wrong, but quick fix. Right, so L-E-E, E-E-T, E-T-C, right, because we start looking at these 3 letters, right, and then we move one over, move one over, move one over, move one over. It's not important. So if C is a space, then that would mean that we're in between 2 words. So that would apply that L has to equal R. If that's not true, right, if C equals this and L doesn't equal R, then we return false. Otherwise, we just keep going. If we get to the end, that would mean that R has to equal this sentence, because R is going to then be the last letter in our system, right, L. That has to equal our first letter in the system. So R has to equal, so we'll return R equals sentence at 0. It's basically saying the very last thing in our LCR pointer, right, this is the last value for R, which is all the way here, has to equal the first letter of the entire sentence. Okay. Okay, now the only exception we need to think about is the fact that sentence could have no spaces, right? So if there's no spaces, then this event will never get triggered. Is that a problem though? Only if, I guess I haven't thought about this. So there's no spaces, so if we have a word that's like ABR, if we have a word that's ABR, then this will be triggered. And then R will get populated as this, and then compare it to A. What if we have a word that's less than length 3? So if the length of sentence is less than 3, so if it's less than 3, it can't be this because there's no trailing space. It could be just an A, and A works, right? Because the last letter of the system is A, and the first letter of the system is A. So that's fine, but what if we had 2 letters? Well, if there's 2 letters, then the first letter has to equal the last letter. So if length of sentence is less than 3, we just return if sentence at 0 equals sentence at -1. And with this we have a linear time solution and a constant space solution, right? Because we're not adding any additional space to save information about the sentence. And the only additional space we need are for a few variables, right? Like variable L, variable C, and variable R. So with that, we'll let this load again, and then we'll submit, and then we'll be done. Of course, it's taking forever to load. I've been noticing quite a few bugs with the updated Leetcode. Okay, so let's go ahead and submit that. And there you go. Way slower, but it is unimportant, right? For space, this is O of n, constant space, and O of n time. All right, thank you guys. Have a good night.